Hi, everyone. I hope everyone's having a very good day. I am currently at the NCTM conference today, but I wanted to leave you with a video of how to do some of the problems from last night's homework that involve variables, because we didn't get a chance to talk about that in class. So I've got the 3 problems that involve variables from your notes here on the screen, and I want to show you kind of step by step how I solve them. We're going to start with the one marked number 7, which is 5z to the negative 4th. And the first thing I need to remember is this negative 4 has a very specific job to do, and it's very specifically attached to only what it is next to. So the thing that it is currently modifying then is this z. It's not modifying the 5. So let's talk about how we can think about doing this. I'm going to show you one way to do it. There might be others that you come up with, but this is tried and true and will help you understand why the answer works the way that it does. So the first thing I'm going to do is I'm going to rewrite this as 5 times z to the negative 4th. And I'm going to do that so that I remember that each of these pieces is going to do something a little bit different. For example, this 5 here, well, there's nothing modifying it, so it's just going to hang around. It's just going to stay a 5. But the z to the negative 4th, now remember that a negative exponent results in taking a reciprocal. So the way that I'm going to think about this is I'm going to think about this as putting the z to the 4th underneath a 1, because the reciprocal of z to the negative 4th over 1 is 1 over z to the 4th. Do you see how that works? So now I'm multiplying a whole number, 5, times a fraction, 1 over z to the 4th. So if it helps you to visualize this better, I can place that over a 1. And now I'm going to do regular old fraction multiplication, which says take the numerator, 5, times the denominator, or times the numerator, 1, and make that a 5. And then take this denominator, 1, times this denominator, z to the 4th, and make that z to the 4th. And I have now rewritten this without negative exponents. Take a moment to go through that and make sure you understood all of the steps. Maybe rewind the video to the beginning and watch me do it again. Okay, if you've done that, then hopefully you're ready to take a look at the next one. Now notice how this one is different. Again, I'm going to focus first on what is my exponent modifying. Well, this time, it's modifying something that's in parentheses. So it's modifying all of the 5 and the z. So now, when I do this, it's going to look a little bit like this. I'm going to take the reciprocal of everything that's in the parentheses, and I'm going to raise it all to the positive 4th value. Do you see what I did there and why it works? Again, this negative sign tells me, ooh, I've got a reciprocal to deal with. And this is what I'm going to be throwing into the denominator of a fraction. Notice I kept it in parentheses because now something kind of wild happens. If I think about this, I'm going to do this the long way so that you can see what's going on. This is 5z times 5z times 5z times 5z, right? That's 5z to the 4th. So really, what happened here is I wound up with a 5 to the 4th and a z to the 4th. Do you see it? 1, 2, 3, 4 5s, and 1, 2, 3, 4 z's, all being multiplied together. So I could leave this like this, but since 5 to the 4th isn't all that hard to do, I'm going to go ahead and expand it out. 5 to the 4th is 625, z to the 4th, so I'm going to finish here. If you stopped here, Good enough. That's good enough. Okay, now let's look at number 9. Well, first, if you need to go back and watch that and watch me do this again, you should do that. Note that this step here, you don't have to write that out. I wrote that out for you so you could see why this happened and this happened. Okay, let's look at number 9. Number 9, I've got 2 variables, and one of them doesn't have a negative exponent. So I'm going to do the same thing I did with number 7. I'm going to write this as 2 separate parts. I'm going to make this x to the 5 over 1 times 1 over y to the negative 7th. Now let's take a look at what I need to do here. This x to the 5 over 1, because this is a positive exponent, it's not telling me to do anything special with the x except to multiply it by itself 5 times. So I don't really have to do much with anything here. If I multiply x to the 5th times 1, that's going to be all I need to do. But this one down here, this y to the negative 7th, that's a little strange. We have a negative exponent that's already in the denominator of a fraction. So what do? Well, I'm going to go off to the side and show you. So if I have 1 over y to the negative 7th, remember that the negative sign in front of the exponent says take the reciprocal. Well, I can take the reciprocal of this. It would be y to the 7th over 1. So even though I already had the variable in the denominator, that doesn't mean I can't take the reciprocal. It just means that now the reciprocal tells me to push the variable up into the numerator. So take a moment to look at that and make sure you understand what I'm doing there. It's really just like what I did with the z in number 7, except instead of going from the numerator to the denominator, now I'm going from the denominator to the numerator. So if I rewrite this, I get x to the 5th over 1 times y to the 7th over 1, and I can multiply those fractions together. Now, since I don't know what x and y are, I can't do anything except shove them up next to each other. I can't simplify that anymore. And 1 times 1 is 1, so I don't really need that 1 in the denominator anymore. I can just do this. So hopefully if you take a look at this and you maybe watch this video 1 or 2 times, you'll be able to see why the answer key gave the answers that they gave for numbers 7, 8, and 9. And now, if you see any more of these in future work, you'll have an idea of what to do. I hope everybody has a great day.